Hello, everyone. My name is Jerry Beanie. I'm the Director of Sales for the Teledyne FLIR Research and Science products. I'm joined here today with my colleague, Mike Roselli, the Eastern Regional Sales Manager. So this is actually our first time at the International Microwave Symposium. And what we're showcasing is basically thermal imaging that can specifically be used for electronics design and testing in industries like RF and microwave transmission and receiving equipment. So FLIR offers a variety of different infrared camera systems, and our segment specifically targets those research and science applications, things like electronics and a variety of other applications. So we have a few different infrared cameras here today that we're showing some of the features of what we can do with those infrared cameras. So on the left-hand side here, we have actually one of our higher-end cooled infrared camera systems that has an HD resolution thermal imager in it, looking at a small little printed circuit board where you can see we can measure non-contact temperature measurements in our software. We also, on the right-hand side there, also have one of our entry-level infrared camera systems, our A700 Science Kit, a little bit more for like gross thermal analysis on a variety of different components. So thermal imaging can be used for a variety of different things within the electronic space, whether people are looking at, want to measure temperatures or measure thermal features on individual discrete components or maybe large electronic components as well. And that can be useful for basically like thermal dissipation, sometimes looking at like thermal efficiencies in the systems, ultimately to improve like the efficiency of the product and make sure there's not a lot of failures actually when it gets fielded out. We actually have displayed here is we actually have thermal imagings from two different cameras. On the left-hand side here is actually a thermal image of basically a small little printed circuit board example that we have. And that thermal image, what you see here is actually, this image is actually a 2D, like a representation of a 2D array of temperature values with each pixel actually being calibrated for temperature. So when it's fed into our Research Studio software, we can do a lot of unique analysis. We can put different regions of interest on it, different lines, things of that nature. And then we can actually look at the individual temperatures per pixel, or we can actually plot them like here, looking at the change in temperature over time. And this is useful for components where you're basically doing thermal testing, where you maybe want to energize it, see the rise in temperature or maybe the decay in temperature over a period of time with it. And obviously, you know, you can do a bunch of different things. We also have line profiles where you can look at basically the temperature value along the line, as well as a whole bunch of other analysis features within the infrared image. So a lot of different capabilities. And we obviously have like not just the infrared cameras that you see here, we actually have a whole family of cameras that can be used for this application. We have some dedicated kits that are specific to electronics design and testing, as well as a variety of different infrared cameras to almost fit any application that customers may need. So if you need more information, feel free to reach out to us at www.flir.com/science. We look forward to speaking with you.